All right, a quick talk through of how we convert degrees to radians and converting radians to degrees. So the most important part here is that when we're converting degrees to radians, if we've been given degrees, we use pi over 180 degrees. And that's the value that we use for converting. So for for example A, 270 degrees. We're going to take 270 degrees and we're multiplying it by pi over 180. And again, we get that from our given. That's what we're using. So in order to convert it, we multiply by pi over 180. So the first thing that I did here is I rewrote this. So 270 degrees times pi, because we multiply our numerators together, gives us 270 times pi. And then 1 times 180 is 180. So I multiplied my numerators together and my denominators together. You could leave it like this and then cross cancel. But I figured I'd put it all together like this first. And then the next thing we're doing is just reducing. So think about 270 degrees over 180 degrees. Degrees itself is a unit that is going to cancel out. So both of these degrees units cancel out. And you'll see in converting radians to degrees that they don't cancel out, and so we end up with a unit. But in this one, our units cancel out, so our degrees cancel out. They're gone. And then if you take a look at 270 over 180, one of the ways that we can think about this is our zeros cancel out. So if those zeros cancel out, then I'm working with 27 over 18. That's a little bit easier numbers to work with to reduce. And the number that goes into both 27 and 18 is 9. So 9 goes into 27 3 times, and 9 goes into 18 twice. And because of that, then 3 over 2. We just reduced. 270 over 180 reduces to 3 over 2. Our degrees canceled each other out, and pi doesn't have anything to reduce with, so we're writing it back over here, multiplying with the 3. So we're taking whatever we've been given, and we're multiplying it by pi over 180. So in this case, we have negative 300 degrees times pi over 180 degrees. Again, what I did, instead of cross-canceling in this step here, I said negative 300 degrees times pi is negative 300 degrees times pi. I just wrote it all one line together. And then 1 times 180 degrees is 180 degrees. So if I were to then reduce, I can reduce my degree signs. They cancel each other out. This negative doesn't have a negative to reduce with. So in my final answer, I'm going to be left with a negative. And then 300 over 180, or 300 reduced by 180. My zeros cancel each other out. And that leaves me with 30 over 18. It's a little bit easier to think. What would go into 30 and 18? And our answer is 6. So 6 goes into 30 5 times, and 6 goes into 18 3 times. I don't know why I wrote 8 over here. Totally my bad. So again, 6 goes into 30 5 times, and 6 goes into 18 3 times. So our answer here should be negative 5 over 3. And then we're still multiplying with pi. Pi doesn't have anybody to cancel out with, so he's just chilling over there as well. And really quick, I'm going to go to my saved photos, and that actually doesn't help me at all. So there we go. All right, really quick, then converting radians to degrees. So this is the other way around, and if you notice, we're just using the reciprocal. So pi over 180 degrees to get from degrees to radians. To get from radians to degrees, we do 180 over pi. So I'm going to take whatever I'm given, negative 4 pi over 3, and I move this negative sign up with the 4, so it's a little bit easier for me to deal with. And then I'm multiplying that with 180 degrees over pi. So when we do this, and in this one I didn't combine them, I'm just going to cross cancel. So check out what happens here. Pi cancels with pi here. And then 3 cancels with 180. It makes it 60. Now if you notice my degree sign doesn't have anything to cancel with. There's no other degrees in either of these that are canceling with it. And so now I'm taking -4 times 60, because that's what that reduced to, and that gives me -240. And degrees stays with that. So hopefully this is clarifying some of the math that happened in the other video, so that you see it. I know it is happening pretty quick. And here for this one, I'll rewrite this so that you see what's happening. So we have our radians, 5 pi over 6. And we're converting it to degrees, so we're going to multiply by 180 degrees over pi. We could rewrite that as, here's how I'm going to write it. I'm going to take my pi, and I'm going to write that last. So I'm going to say 5 times 180 degrees times pi. Think about 4 times 3 times 2, and I could write that as 4 times 2 times 3. I can change the order, and it's still multiplying. So if I say 5 times 180 degrees times pi, essentially all I've done is I've taken these things, I rearranged them a little bit, but it means the same thing. It doesn't change what the outcome's going to be. It just helps me see my numbers with my numbers and pi with pi. Down below, I have 6 times pi, and there's not a lot going on there, so I'm just going to leave that as 6 times pi. Now, I'm totally allowed to multiply these and then divide or reduce by 6, but one of the other things that I'm allowed to do is that I can reduce anything that I see in common before I multiply things out. So I see this pi is going to cancel out with this pi. These guys take care of each other. I'm looking at 6 and 180, and I'm thinking, man, 6 goes into 6 once. 6 goes into 180. If we divide that, 6 goes into 180 30 times, right? And it still has that degrees there. I'm going to include the degrees up there. I just rewrote it kind of with the 30. And now I'm saying 5 times 30, which gives us 150. All my other stuff canceled out. If I had anything in the denominator, I would write it. But over 1, I mean, I can say 150 degrees over 1. It means the same thing as just 150 degrees. In our other one, our denominators canceled out as well. If we had a denominator, we would leave it. In this case, we don't. So these are positions then in our kind of in our circle, in our unit circle, and then we could use these positions to help us find kind of where our terminal side belongs. So we started our initial side and then moved to our terminal side based on these positions. So hopefully this helped explain how we are getting from degrees to radians and how we get from radians to degrees. We use pi over 180 degrees and multiply it with our degrees, or we take 180 degrees over pi and multiply that with our radians, and then that helps us find. So they're like interchangeable. They mean the same thing. They're just two different versions of the same thing. So hopefully that kind of helps you connect those dots.